Hello guys, my name is Desmond, well known as Dish. So in this lesson, I'll be answering and solving questions where I'll be teaching you guys and training you on how to analyze given statements, diagrams in relation to given questions. And most importantly guys, I'll be providing you with necessary tips specifically for this question and additional exam tips to use when attempting other exam papers. And of course, as always, in the end of this lesson, I'll show you how and where you score full marks. Okay, so without any waste of time, I think we can now have a look at the given statement. So I'll just quickly read through the statement, and then from there we can start with the questions. So 2.1, as you can see, we're given a statement and it reads as follows. An 8 kg block P is being pulled by a constant force P up a rough inclined plane at an angle of 30 degrees to the horizontal at constant speed. So force F is parallel to the inclined plane as shown in the diagram below. Let's see. So can you, okay. All right. I think if you've noticed from almost all of our questions that we tackled previously, so what I usually do is to first read the statement if we're given a diagram before starting with the first question. What I normally do is to then try to go through the diagram and try to actually interpret it, so that in case if you had a different way of interpreting the graph, you can then somehow make use of some of the information that I can give and also use it to empower yourself, just to add on the knowledge that you already have. Okay, so let's see. I've just drawn a diagram. So as you can see, we've got a block which is named P, and the block is 8 kg, and obviously it's being pulled in that direction at a certain magnitude of force. And remember guys, they just indicated that it's being pulled up a rough inclined plane. So that means it's been pulled on a rough surface. So this is an incline which is at an angle of 30 degrees. So we can just assume that you've got a flat surface, and when it gets to that point, it starts to incline at an angle of 30 degrees. So is 30 degrees relative to that flat or horizontal surface? So it's more like you now have, let's say this is the soil. So now when it gets to that point, there's an angle of inclination, and then now it gets, so in short, it gets steeper at an angle of 30 degrees. It was flat, then it starts to be steeper now. Steep in that direction at an angle of 30 degrees relative to that flat surface. So which means it's actually moving up an incline at an angle of 30 degrees relative to the horizontal. So I think so far we can just make use of this information to see if we can be able to answer upcoming questions. So there's there's nothing much given on this diagram. I think what we have discussed so far, it should be enough for us to get started. Otherwise, if there are any additional questions, I think during the lesson you will just pose those questions and then I will attend to those questions. So I'm just checking here. I'm not sure if there's a need for me to go through that statement to try and interpret, but I think everything it's clear, guys. They've indicated that block P, it's 8 kg block, which is being pulled by a constant force up inclined a plane which is rough and at an angle of 30 degrees to the horizontal. I think I've covered that part. And again, which is the most important thing given on this statement, guys? This block P, it's moving at a constant speed. Let me just write it down there to say at constant speed. So it's that statement, guys, it's very, very, very much important. And for the fact that it's even written in capital letters, it means we have to bear in mind that the 8 kg block, it's moving at a constant speed. So I think on the upcoming questions, I'll show you how important that statement is. And I'm assuming on the other questions that you might be treating, please take note of whatever that is written in capital letters. It could be your key to having full marks on all the questions, because I assume at this stage you understand that your first question, in case if you get it wrong, then it might affect your upcoming questions. So I think it will benefit you a lot if you pay attention to this part where we'll be using that statement given in capital letters, constant speed. Okay, so I think at this stage we can move to question 2.1.1. Let's see. So the question says state Newton's first law in weights, and this question is allocated 2 marks. So for this one, guys, I don't think we should waste a lot of time on this question, because obviously in almost every books for physical sciences, they always state Newton's first, second, and third law. So you can just get that information from any textbook. Make sure you know it by heart, and most importantly, make sure you understand Newton's laws, all of them. So in this case, we're only required to state Newton's first law in weights. So what I'm going to do, so that we don't waste much of time, I will just state it, and then afterwards I will write it down so that you can be able to copy, just in case if you feel like you want me to just write it down. So for now, you can just listen very carefully, and then afterwards I'll write it down so that you'll have enough time again to just copy the definition. So in answering the question, you just simply indicate by writing down in words that an object continues in its state of rest or uniform motion, which is moving with constant velocity, that was in brackets, unless it is acted upon by an unbalanced resultant force. Of course, there are multiple ways in which you can define Newton's first law. I'll just give you the second definition, which still refers to the same thing, but then it's only that it may be written differently. So one may say a body will remain in its state of rest or motion at constant velocity unless a resultant force acts on it. So it's just a matter of you guys choosing which definition suits you best, and again, which definition you think you understand better and you won't easily forget. Okay, so as promised, I'll just write it down. Okay guys, so this is your opportunity to then copy the definitions if you feel like you need to write them down, but otherwise you can still, as I've indicated, you can still get them from either previous, I'm sure in every textbook there should be a definition for Newton's first, second and third law. So let's see. Okay, so in every definition that you give, especially in physical sciences, guys, there are some parts, there are some parts in your definition which, they must be mentioned. So I've actually underlined those words or phrases which must be mentioned in every definition that you give, especially when we talk of Newton's first law. So those that I've underlined, they must be mentioned in your definition. But also the other parts of your definition which are not underlined, they should also match and correspond with those which are underlined. So you shouldn't just write what I've underlined there and say, out of all of that sentence, it's only those underlined which are important. So everything is important, but those must be mentioned in your definition. So you might find that some of you guys will be breaking the rule of Concord in your definition, but otherwise it's a different story, because in this case we want you to mention those which are underlined. So I think for now, guys, we can move to question 2.1.2, of which I think I'll just do a separate, I'll just do a separate video for that, because I see we've spent a lot of time on this question. But I think the information that I've given, it was worth it, I think. So just please let me know in the comment section what you think of this lesson. And also, if you've got any other specific information that you'd like to share with the rest of us, you can just drop your comment in the comment section, and we'll also learn from your experience as far as question 2, which is related to work, energy and power. So I think without any waste of time, guys, let's now move to the next question.